Alright, boys and girls, welcome back to the drive-through for a 9-5 edition right before spring break. We're going to go off the script a little bit for this, and when we're done, my goal is that you understand what a regression line is, understand what a correlation coefficient is, and then finally understand how to do this in your calculator. Okay? So what we're going to do is we're going to plot set A in blue, okay? And we'll plot set B in red. Sound good? Okay. So let's see. Over 1, up 2. Keep in mind I have over 1.5 up 2.3. Over 2.5 up 3.3. Over 3.7 up 1.9. Over 4.2 up 1.8. Just stay with me, Carson. Don't worry about anything yet. As you can see, these are making maybe a predictable pattern. Where were we there? Over 4.6 up 3.2. Over 4.5 up 4.5. Finally, I can get that one right. Okay. Over 5 up 3.7. Over 5.5 up 1.7. Over 5.7 up 4.8. Over 6.1 up 2.7. Over 6.4, is that right? Yeah. We're in the last one? Yeah. Over 6.4 up 2.3. Oops. Right there. Alright, let me pause it. Alright, Carson. So now, a regression line is a line that best estimates this set of data, okay? So it looks like there is a trend here. Think about it, like people that study more often usually get better grades, but don't always get better grades. So we're looking for apparent trends. And it appears to me that this line might be something like, I don't know, something like that. Like that might be a line that kind of estimates that stuff. Okay, now let's do the same exercise for the green ones. I'm sorry, for the red ones. Okay, so 2, 1, we start with the same point. Oops. 2, 1. Okay, and then 2.3, 1.5, that's the same point. 2.3. Where is that? I must have missed that or plotted it wrong. Oh well, I'm going to go on anyway. 2.3, 1.5. 3.3, 2.5. 3.3, 2.5 is there. And 3.7, 1.9. There. 4.2, 2.8. There. 4.6, 3.2. There. 4.5, 4.5. Again, that's one I can get right. Although, why don't I have that? No, that's 5.5. Let me back that up. Right there. 4.5. 5, 3.7. pretty much right on the line, I think. Oh, no, it would be there. That one's back on there. Okay, 5.5, comma 4. Right there. 5.7, comma 4.8. There. 6.1, comma 5. There. And 6.4, comma 4.6. Bless you. All right, so you can see that the red line also has some sort of a correlation. And I'm just making this up, Carson. I don't know. Let me try to sketch a line that has the red points on both sides of the line. I don't know. I think I might need to do this. Start it down like here. So you can see the lines are pretty close to each other, okay? Can you see why this might be a useful tool?
Maybe it would be to like a...
Look, we're going to use this tool to try to predict the future. So let's just say we've got like I don't know, what could we have on this axis down here? How about years of college? How about years of school? Years of school, exactly, and wage. Okay, now we shouldn't have this axis. We'd only have positive things here. You can't go to school for a negative amount of time. You really can't earn a negative wage. But like, what if we got a bunch of data that was like this? Okay, it does look linear. Excellent. So if we were like, okay, let me make a prediction. So let me just get an equation of a line, and we got the line, and then does this line look like it's positive or negative slope, positive or negative intercept? So maybe this is something like y equals 4,500x plus 2,000. Yep, just make it up. Well, okay, now we could like have something useful out of this. If I went to school for 30 years, then I would make 30 times $4,500, which is 120. What's 140? It'd be $147,000 if I went to school for, did I say 30 years?
Yeah.
And I think that's right, but I don't know. I just did it in my head. That's all what we're doing here. Take data, plot the data, make a line. It's called a regression line. And then there's this correlation coefficient, and that tells us how much confidence we should have in our line. Okay? The best the correlation coefficient can be is 1. If it's 1, our line is perfect. If it's 0, our line has no predictability. It has no we have no confidence in the fact that our line is going to predict the future. Got it? That is called a correlation coefficient. And all you need to do is be able to do this in your calculator. But I'm telling you right now, you're going to need to get help from me. Okay? Let me pause this and get this set up. Okay. So, now I'm going to show you how to do this. It's pretty complex. You're going to go to Stat. Okay? And then we want to edit. And here I've got an empty list. On the top list, we need to type in all of our input values, or our x values. So 2, enter. 2.3, enter. 3.3. You doing this with me? Enter. 3.7. Enter. 4.2. Enter. 4.6. 4.5. 5. 5.5. 5.7. 6.1. 6.4. Now go over here to the second list. Okay? What do you think we're going to type in for the second list? We're going to do the same thing with the Y values. So the bottom values. 1. 1.5. 2.5. 1.9. 2.8. 3.2. 4.5. You double checking me on this? 3.7. 1.7. 4.8. 2.7. 2.3. Does the 6.4 match up with the 2.3? Yes, it does. Now we're in good shape. Okay? Now, just go second quit. And I do that so the lists are there until your calculator gets cleared. They will always stay in there. Okay? Now go up to stat. And now we want to calculate. And you see this linear regression. 4. You stat. Calc. You see this linear regression? Now, there's something else I want you to know. Look, you got quadratic regression, cubic regression, quartic regression, so we can do these at a higher level for quadratics. But right now we're just going to do linear, okay? Hit 4. Is this what yours says? Alright. We got L1 and L2. You may not have that. If you don't have it, you'll see it down here in blue. So you'd have to do alpha 1 for the first one. No, not alpha. Second 1 for the first one. Second 2 for the second one. Mine's already in there. I'm going to scroll down to calculate. Hit enter. Okay, now there's a problem. It gives us the equation. Check this out. This is pretty cool. You'll recognize this. It says y equals ax plus b. It gives us our a and our b. So the equation of this line, and this was the blue one, so let me change my font. The equation of the blue line would be y equals 0.41x plus 0.8945. Okay? But it doesn't give us our correlation coefficient. And if you're not Carson, you're not watching this video, I'm pretty confident you're going to need my help with this. Okay? What we want to find, where is it? Down here, this catalog button. So we're going to hit second 0. And we're going to go all the way down to the D's. And I'm really sorry about this. This should be the only time you have to do this. And under D's, you want to get to where it says diagnostic on. Okay, now we're hitting enter. Alright, now we have to do it again, Carson. So we've got to go stat, calculate, linear regression, get down to calculate, enter. Oh no. Did yours switch? Okay. Let's pause the video. Okay, I realize what I did. After you clicked on diagnostic on, you had to hit enter again till it says the dishes are done, man. Alright, now let's try it again. So, ready? Stat. Calculate. 4. Go down to calculate. Enter. There we go. So our R value is 0.496. Okay? Now we're going to go through and do this again. And where's my maximize? There it is. We're going to go through and do it again with the red ones. Which data looks like it's more tightly put together?
Looks like the red.
I agree. So which one, Carson said red. So which one would you hypothesize is going to have a higher correlation coefficient?
I'm going to guess
the red one. Very good. Okay. I think if the red one is indeed a more tightly bounded group of data, then it's going to have a higher correlation coefficient, right? So let's go back into our list now. So stat and edit, so you get 1. Now I'm actually going to go over to my first list because a lot of these are the same. Did you notice these? 2's the same. 2.3, 3.3, 3.7, 4.2, 4.6, 4.5, 5, 5.5, 5.7, 6.1, 6.4, all the same. So now all we got to do is change some of these. So the 2 is still a 1, 1.5, 2.5, 1.9, 2.8, 3.2, 4.5, 3.7. Oh, there's a different one, right? That should be 4. Enter. 4.8, the next one. Nope, 6.1 should be 5. Enter. And the last one should be 4.6. Enter. Now, what are we going to do now? We're going to quit. Then we're going to stat. We're going to calculate what? Exactly. Go down to calculate. Ooh, now the things have changed. So the red equation has a much higher slope and a slightly lower y-intercept. Y equals 0.897x plus 0.693. And what's the correlation coefficient?
0.935.
So which one has a higher correlation coefficient? The red one. You were right all along. So that means how well will this line predict future data? This line has a much better prediction value than this one does.
So basically, it's kind of like Google Auto. Like it's 0.9. It's basically 93.5% possible that it's going to predict.
It's just all we want you to know is it's more likely to predict a close answer. And that is what you need to know to do this lesson. We're keeping it under 20. We're rocking our way into spring break and 7th bell. Shout out to Preston. Boom!